Hello student, the question says two uniform solid spheres of equal radii r but mass m and 4m have a center separation 6r. As shown in the figure, the two spheres are held fixed. A projectile of mass small m is projected from the surface of a sphere of mass capital M directly towards the center of the second sphere. Obtain the expression for the minimum speed v of the projectile so that it reaches the surface of the second sphere. So here two spheres are given. One is capital mass m, another one is 4m. Both have same radius. It simply means that the density of this second sphere is much more greater. And we are projecting a mass m directly towards the second sphere. So we are projecting it directly towards the center of the second sphere as shown in the figure. One thing interesting about this question is why can't we project it from here? Why should you directly project it from here? Because the words are given, we have to obtain the minimum speed required. Since minimum speed is required, the distance from the surface of this planet and surface of this sphere must be minimum. So we are projecting it from here. And let us study about this problem in detail. Now, this is the basic thing that is given in the question, and the radius of this are they are separated by a distance of 6r. Then what is this n that is given in the question? This is basically a null point. Null point is a point where the net gravitational field would be zero because of both the masses. That means, suppose if I throw this m from this surface, this m would go in this way, and after some time again it will come back to this sphere only. Why? Because from here to null point the net force would be towards left. That means the left side sphere would attract more than the right side sphere. So if I throw this mass, it will go and again it will come back. If I throw it again, it will go and again it will come back. But once it somehow crosses this null point is a point where the net force is zero. Like imagine if I have this mass m and I placed it exactly on the null point. If I place it exactly on the null point, this mass would neither go to the left nor it goes to the right. It will stay here only. But if it somehow just crosses the null point, if it just crosses the null point, then the mass would slowly drift and eventually reaches the surface of the other sphere. So based on this, now since the question is all about finding the minimum speed, since it is about minimum speed, we have to make sure that our mass somehow crosses this null point. Once our mass crosses this null point, the gravitational force due to the other mass would slowly pull it and our mass would go in this direction. Now first let us find the position of the null mass. So the first step would be finding the location of null point. As I told you, null point is a point where the net gravitational field would be zero. So gravitational field due to the first mass would be G. We can equate net gravitational force to be zero also. So G into capital M divided by the distance between the center of this and the null point is R. So Gm by R square must be equal to the field due to this, because the field due to this sphere would be in this direction. Let me call this E1. The field due to this would be in this direction. Let me call this as E2. So at the null point, E1 would be equal to E2. So G into this is 4m divided by, if this is R, total is 6R. So this one would become 6R minus R. So we get 6R minus R whole square. So if I solve that, Gm we can cancel Gm if I cancel it and bring this to this side, we'll get 6R minus R whole square divided by R square equals to 4. Apply square root on both the sides. 6R minus R by R equals to root 4. So we got 6R minus R by R equals to 2. So based on this, 6R by R minus 1 equals to 2. 6R by R equals to 3. So based on this, we get R equals to 6R by 3. So simply R value, we got it as 2R. So at a distance of 2 capital R from this planet, we are getting the null point. Let me take this to the next page and redraw this diagram. So once we got the location of null point, let us redraw the diagram. We got small r as 2r, and this one would be 6r minus 2r, so it would become 4r. Now we have to give it a velocity v such that it crosses this null point. Let us use total energy equation to solve the problem. Work energy theorem. Work energy theorem says that initial energy equals to final energy. What is the initial energy? It is simply initial potential energy plus initial kinetic energy is equals to final potential energy plus final kinetic energy. Initial potential energy of this mass and this mass, it is minus g into capital M into small m. What's the distance between them? Distance between them is radius r. So it would be r minus potential energy plus potential energy due to this mass on this small m. Potential energy due to this mass on this small m. The total distance is 6r. We know this distance is r. If the total distance is 6r and this distance is r, the distance from this small m and this 4m, it would be 5r. So let us substitute it. Minus g 4m into m divided by 5r. So we got initial potential energy plus let us assume we gave it a velocity v. So the kinetic energy is half mv square. See, there will be potential energy between these two masses also. We can ignore the potential energy between these two masses because it will cancel on the left side and right side. There would be one more term, gm into 4m divided by distance between them 6r. But since it is present on the left side and right side, we can cancel this term. Right now, we no need to write it. Equals to final potential energy. Once this mass comes and reaches here, once this mass reaches here, the new distance between them is 2r. So we can write minus g mm divided by 2r, again minus g 4m into m divided by 4r plus the final kinetic energy would be 0. Why? Because our goal is to find the minimum speed. Even if it somehow manages to reach this null point with 0 speed, even if it slightly crosses this null point, from here onwards, the gravitational field due to this larger mass will slowly pull it towards it. It does not need to have any velocity once it reaches the null point. Since the word minimum speed is used, so the final kinetic energy would be 0. There could be a question you might get, if it exactly reaches the null point, then it will stop right. Why it will go to the right? Generally, in these kind of questions where minimum and maximum is done, we will assume that if it reaches the null point, our goal is reached. But practically speaking, it has to slightly, very little. Like example, null point is, as an example, let us say it is 10 kilometers. It has to reach 10.0001 kilometer. It has to slightly cross the null point. But anyway, we will assume that it reaches the null point and that would give us the minimum velocity. Now we have to find the velocity value. Half mv square equals to gmm by capital R plus 4g by 5r minus gmm by 2r minus by r. So we'll get half mv square equals to, if I get by r as common, we'll get 1 plus 4 by 5 minus 1 by 2 minus 1. I can cancel this one and this one, and we'll get 4 by 5 minus 1 by 2 as 10, 8 minus 5. So we'll get it as 3 by 10. So half mv square equals to 3 by 10 gmm by r. So we can cancel this 2 5 times. But this m we can cancel it. So finally we get the minimum velocity required equals to root of 3/5 of g into capital M by r. So this is the minimum velocity required for this small m to exactly cross the null point. So let us quickly go through the steps that we have done. Initially, the most important thing you have to know is what is a null point. Null point is a point where the gravitational field becomes zero because of these two masses. Next, what is the meaning of minimum speed required? Minimum speed required is a speed that will allow us to cross this null point. So that's the key concept. Once this body crosses the null point, rest of it would be taken care by the gravitational pull of this larger mass. So somehow if it manages to cross the null point, our problem is done. I hope you understood how we have solved this problem. I'm unable to hold this mass. So this mass will somehow go to this null point, and from this null point, it would reach here. And one more thing, since you gone through this entire problem, there is a shortcut to find the null point. It is better if you remember that shortcut formula also. That is, if you need a distance of the null point, R1 would be root M1 into D by root M1 plus root M2. This will help you to solve these kind of problems very quickly. Here root M1 is given as M. Distance between them is given as 6R divided by root M plus root 4M. So if you know this formula, you can directly find the null point as 6R by 1 plus 2. So it would be 2R rather than writing that net force is equals to 0. This will help you in competitive examinations. Hope you understood how I have solved. Thank you.